Hey guys, how you doing? It's my afternoon, and at the minute I've got to machine some brass. So what I'm going to do, turn this off, and this off. What I'm going to do is I've already set up the chuck. We're doing this brass, which actually I'm not sure what the dimensions are. I ordered it for something else, and I'm going to be using it to make some recess lights. So essentially, these are some recess lights that I turned earlier out of 1-inch bar. These need to be bigger. Basically, these ones have got a 25mm bottom, and these are 25mm overall on the biggest dimension. So obviously these would be no good for what we're trying to use here. And the idea is that we're actually going to get a 3-watt LED in these with a nice narrow optic to put some really nice beam angles up the side of a house for a landscape contractor. So what I'm going to do is I'm going to get the GoPro set up, and I'll get you in the cab and you can see me load the chuck in, etc., and we'll get everything started. Right, so let's get this in. Let's get the chuck in first. So what we're going to do is we're going to put this on lock. There we go, and get the chuck in place. And it only has to be hand tight. It rotates in the direction it won't come loose. The chuck actually has to be, well, the drawbar actually has to be clamped, even though it makes zero difference to anything we're doing. Now, what I'm going to do is I'm going to measure the dimensions of this, and then we'll start working out a program to get this machined. And what we'll probably do is do the internals first, and then we'll flip the part round and do the face. And we'll probably keep the dimension here, the OD, as the top rim, because it's going in a gravel as far as I'm aware. Okay, so I've got to use my poor man's calipers, which are the mechanical dial ones, because I can't find the digital ones anywhere. So the OD of this is about, yeah, about 44mm, which sounds about right. I think that's about what I ordered. 44. Oh, actually it's moved a little bit, 45mm. Okay, so when we program in the machine, we'll basically work it on the basis of 45mm. The plan is, because we're using standard spike backs for the bottoms, like we do for the halos, etc. The plan is, what I'm going to do is I'm going to copy the program for the spike front, and we're going to machine what is essentially the spike front via the back. But obviously it's just going to have a really big flange, and it's going to have to be done in 2 ops, because you can't, with the chuck, you can't actually machine it all in one hit and part it off. It's just because the jaws are in the way, etc. So we'll do it in 2 parts, but I'm going to copy over the front part first, get that in ready, and machine that first part. We'll get it on the GoPro and you can see what's going on there. Okay, I just had to change out the chuck for the bigger one. So you can see the big chuck here. What I've done is I've stuck in a bit of bar and a collet behind, so that's a stop, so that we can have our part back here consistently. And the reason for that is I need to machine at least half the part on the OD. Otherwise, we're not going to be able to. I'm not going to be able to complete the part. So to me, that makes the most logical sense. Now, the only nervous thing about this is I've never used this chuck on the machine ever, and it is a monster inside this machine. But we've got very, very little distance to play with in terms of our machining. That's my job is over. You can see that there's about 50mm of play there, and that's it. We're on stops on the Z-axis. But yeah, we should be able to make that work. So we'll get that set up and get ready to go. So I've run a test part, which is this one, just to make sure that everything's all clear and to adjust our splits to the program. That's the first part of it. So I'm going to run it really quickly on the lathe now at full speed, and you can see what it looks like. I've got 4 drill chuck on this. Done. Right, so I'll leave that to run. So guys, we have started machining the other half of the tops. So basically, Jamie this morning has been running these tops just on the second op, which basically gives us this beautiful face. It's a really nice size. This is, I believe it's going in gravel, so it will sit really well in that. It's got quite a small opening aperture. Yeah, and what I'm going to do is I'm going to get the GoPro inside the cab, and you can watch one part be machined start to finish in there, and then hopefully I'll get to do some assembly and show you the final product. Hey guys, so another new day. I've got a new lens on the DSLR, so you can kind of see a bit more of what's going on. Oh, the oven just went off. We'll just quickly pop that open. There we go. Oh, right. So I anodised the backs for these brass tops. So we've got these lovely brass tops that I wasn't gonna brush, I was gonna leave them, but I think they're gonna have to be brushed, just because it's the kind of best way to get rid of any little scratches and marks, etc. But basically we're gonna take an aluminium back like this, and I've basically anodised this, and I'm just anodising some more just to try and get the colour right, because the anodise is a little bit it's a little bit light in places. Look, I mean, this one's got a little light patch here. It's not, it's not the end of the world. Anodising for us is still something that we're still trying to get right. I mean, it's protected. It's just the dye process just didn't sort of come out as well as it could have. We will get it right at some point. So that would be the idea of how the fitting will sit, and obviously you're only going to see that top anyway. But we just wanted to anodise it just to give it a little bit more protection. Look, there's some sort of white stuff on this. So what I'm going to do is I'm going to set up the laser and just laser the backs of these. I was going to wait until I get two better ones, but I think these are okay. I'm not that worried. It's not something you're going to see. It's protected. I might change my mind later. We'll see. So with the laser, what I've got is I've got these little 3D printed holders, and basically the positioning should be the same every time we laser one of these. So let's just quickly grab the company this is for and the fitting, recessed brass, there we go, and that gives us our serial numbers, etc. And this system's being redone at the moment, but basically that kind of gives you an idea of, you probably won't be able to really see it, but it gives you an idea of how we kind of see the fittings as they come through. So we have to load the program appropriate for that bit of laser in, which in this case isn't going to be under sparks, it's going to be a mark back of light. I just need to change the name on the back of this light, saved as the last one. And I need to change the serial number, which starts at 629. Funny, because the last one was 701. It's just the way that it gets added to the system and what order certain things are done. Admittedly, this order is late. And then I'll do the red just to make sure that the laser's marking in the right position, and I can see that looks pretty good to me. So I just hit the space bar and just mark. And the mark comes out pretty well, and we do this on every single fitting that we make. We do it on like the whisker spikes, etc. It gives you a bit of customization. So just to give you an idea, hopefully we'll be able to get this in focus, but yeah, so it's got the proudly installed by Garden Solutions. It's got the serial number 629, Hudson Lighting, made in England, and yeah, that's just how we mark every fitting. Which is an idea. So that's the first step. So I'm going to get on and do all of those, and then we'll come back round. I'll show you the rest of it. If you notice that this is my daughter's sock. We upcycle everything here, so if you get a box from us and it's got plastic bubble wrap in it, we didn't buy it, we reused it because we got it in another order. I don't want to send it in the bin. I'd rather it actually, you know, live another life sort of thing and serve a purpose again. Same with things like clothing. A lot of stuff that if we can't use or can't sell on, what we do is we cut it up for rags. Works perfectly for us here, and again gives everything a second life or a second use until it has to eventually be disposed of. And we actually do send the good stuff if it can't be sold. We, you know, like do it in the recycling bank, that kind of thing, so at least it gets used like that. And it's only the stuff that really won't get used that we break down for rags, but yeah, does the job. And we used to buy microfiber cloths like these. Of course, I don't know if you know, but microfiber cloths are actually like plastic. I think they're polypropylene, which is, you know, it's really terrible for the environment. And even if you wash something like that, rewash it to reuse it, you get microplastic in your washing machine that goes in the drain and goes out to the rivers and then eventually to the sea, and it won't get treated and filtered out. So there's another reason for microplastics in the oceans, for polypropylene stuff. Good reason why I need to buy a cotton clothing as well, but we'll leave that as a separate discussion for another day. Okay, so those are lasered. The next thing I need to do is assemble the protection circuits. So kind of out of shot around here, which I'm just going to grab, there is a load of protection circuits, and I'm just going to grab one, and just to show you the assembly. Oh, lead under there we go, and show you the assembly one. So this is one we made earlier, and what we're doing is we're going to start injection moulding these. Probably in about 8 weeks or so, when there's a company in West Sussex, Travin, that we've been talking to, that we sort of discussed something that we want to do, which is basically injection mould these in situ, i.e. printed circuit board with lead on, bang it into the injection moulding machine, and it moulds the whole case and everything in one hit, which will save a lot of time and a lot of errors and so on and so forth. So yeah, I mean, that's the plan. Hopefully that works out. But yeah, so anyway, for assembling these lights, what I do, a little dab of silicone spray there, a little silicone spray in there, pop that down inside. We have a O-ring that goes on the outside, and then we have our heat compound, which goes, can you see this? I don't think you can see this little rim just here. It basically goes around on that rim, if it will come out. There we go. Oops. There we go. So that's it in there, ready to go. Then we need our LED, and these are 2700K 3 watts, which I have a feeling there isn't any 2700K 3 watts. There's loads of 1 watts, no 3 watts, which means I've got to go make some. So while I'm on the subject of having to go make some, I'll leave that there. I'm going to show you something new. And I'll probably do a whole separate video on it, but I had these laser cut and they just arrived this morning, these little discs, and the idea is that we've got new balls. Hang on. So These are old boards, aluminium board, 1.6mm thick, with our circuit on the front, bare aluminium on the back. Now, you're probably thinking, well, that sounds really great. And it is. It's, in terms of heat dissipation, very good. The problem is that we use brass pins, like these tiny little brass pins, like that, and they go through the board. Now, you've got 3 pins on each one, and you need to make sure that these pins don't contact the aluminium, because otherwise they'll short everything out. And that has been a huge challenge for us, and we haven't always achieved it. And so what's happening is we're making up these, which is 25 boards, and we're getting a failure rate of between 10 and sometimes 50%. Now, if you think that if we use it depends on which LEDs we use, but let's talk the more expensive end. Our XHP50 Cree LEDs are £4 for us to buy each. So if you're having to pretty much throw away a £4 a board with a £4 LED and a 30p pin for each one, oh, and then there's a red LED that's like 81p. What's that? It's like £5 of components right there. More than that, £6 of components, especially by the time you add the board. So every one you fail, it's £6 going into waste. So what we were trying to do is, how the hell do we build something that we don't have to worry about that issue anymore, and yet we still need to deal with the heat dissipation? And what we've done is we've had these made, which are super thin, and I've got I've got ones that are 0.6mm thick and some that are 0.8mm thick. So we're going to test them between each other and decide what we're going to do. What they use is there's plated through holes onto a heat pad on the back, and the idea is that we're going to use some heat compound on the back to adhere to this, or not to adhere, just to basically shift off the heat, and our pins will come through that little slot, and then as a whole that will go down into our fitting. So that should mean that we'll get 100% pass rate on these. I mean, it's probably going to be like 99.99 whatever, but that's the idea. So obviously I'm going to have to build some of these, so I'm going to do a separate video for that, and yeah, keep an eye out for that one. Right, so we just 3D printed these little baffles. So they're going to go on this narrow optic, and they just literally just squeeze straight over it just like that. And then I basically just give them a little clean up with a knife, just to get the little hairs off, but I mean, generally it's not too bad. Then we've got our machined top at the moment. This one is it's machined at the minute. We're going to go to injection moulding it in probably about 2 months or so. Hopefully then that will make the processes a bit quicker. So we've got our O-ring, pops on there, silicone spray inside the brass, silicone spray on the optic, on the lens, pop that in there, push it down. We do have a little tool for it to push it down if we need it, which is this little tool here, and that just pushes it in. Then we take our top, make sure I've got one. This is one I've already assembled an LED on. Lens just pops on top, just like that. You can see it's really super narrow. I think this is 14 degrees, this one. And then finally our top screws on. It should be quite tight, which is good. Yeah. Just give it a little clean up. We'll pop it in the water and it will have a final clean at the end anyway. So if I get this lead apart, if I can find out which one it is, they've gotten a bit of a tangle. And what I do is I check both sides. So I'll tell you what, we'll just push it in and then I'll push it in properly in a minute. So this should be red, yep. So that shows that it's connected around the wrong way. And then this should be our actual white, which is really narrow. So then what we do is we basically connect this lead up properly and bung it in the tank, essentially. With it on. There we go. And in the tank it goes. And that's it.